contract to the Ethereum blockchain and sending a transaction to it. So indeed, that's what you've been doing every single class. There's a contract that resides in the Ethereum blockchain, actually the testnet, and you've been sending a transaction to it. A piece of data goes to that contract, and that's how we know that you actually check in for class. So what's going on? So the first thing, let me talk about the differences between Ethereum and Bitcoin. So Bitcoin's always a good place to start, and it's kind of the version 1.0 of a blockchain-based cryptocurrency. So in Bitcoin, you can send transactions. So we learned how to do that with the so-called unspent transaction output that you effectively destroy by sending part of it to somebody and the rest or the change to back to yourself. So in Ethereum, there's many different similarities, but in Ethereum, you can do more than just transact. So there's two types of accounts in Ethereum. One is just an account that does a transaction. So you send an Ether to somebody else. But there's another account called a transaction account. And this is where you can deploy a computer program into the Ethereum blockchain. So this computer program we need to be careful about, because one danger is that somebody puts a computer program into the Ethereum blockchain, which means that that program goes on every single node. And a danger would be if that program was running in an infinite loop and taking computing time and effectively draining the network of its computing time. So the idea of the Ethereum founders was the following. We can set up a computer program called a smart contract in the network, but it needs to be triggered by a transaction. And effectively, the terminology actually is gas. So you actually pay for some gas that fuels the computer program. And this gets rid of the problem of the infinite loop. Think of it as a car that is out of control, maybe a self-driving car on the highway, and you can't control it, but it's just going, continues to go. But it will eventually stop because you run out of gas. The same thing here. So you basically submit a contract to the Ethereum blockchain. And in doing that, there's the usual fees like we have in Bitcoin. But then anytime anybody sends a transaction to that contract, they need to pay a fee called the gas fee. It's a very small amount of money, but that gas fee is part of the reward that the miners actually reap. So very similar to Bitcoin, this is a proof of work technology. The miners get rewarded for putting a block on the Ethereum blockchain. They get rewarded with a Coinbase transaction, which will soon be 2 Ether. They also get rewarded in terms of collecting all of these gas fees. So that is very similar in terms of Bitcoin. Ethereum will be moving to a proof of work technology, and this will allow them to confirm transactions and to run these smart contracts at a fraction of the energy cost that currently is paid within the Ethereum ecosystem. It's also the case that Ethereum blocks are much faster than Bitcoin blocks. So Bitcoin about every 10 minutes, Ethereum's about every 15 seconds. When Ethereum goes to proof of work, I expect that 15 seconds will go to something closer to 1 or 2 seconds. So the proof of work will is actually slow. The proof of stake is a lot faster. When Ethereum goes to proof of stake, again, I expect 1 or 2 or maybe 3 seconds with proof of stake. So this is the basic structure. Again, you've been sending at the beginning of class, you've got actually 2 wallets. It's interesting. So you've got your Coinbase wallet that I seeded with $1 of Bitcoin. You can easily transfer that into Ethereum. So you can have a fraction of an Ether on your Coinbase wallet. You've also got a MetaMask wallet. So there's a number of differences. So the Coinbase wallet, you trust Coinbase with your private key. the MetaMask wallet, you actually have the keys. And that's why all of the security you had to go through with all of those words in a certain order. So you have your own keys in that MetaMask wallet. So for the attendance logger, we set the contract up in the testnet. And then in the first class, you got some test ether. So they're not worth anything, and this is just for testing code. And we could have deployed the attendance logger in the Ethereum blockchain. It would work the same way, but you would need to pay real amount of money to actually check in. Now that amount of money is not that much, maybe 10 cents, but we thought it would be easier to run it in the testnet. Okay, so that's the basic story. Again, there's many similarities. Ethereum uses a different type of hashing, but it's a 256-bit output, just like a SHA-256. It's a SHA-3 class, which is much more convoluted than the SHA-2. There's a lot of similarities, but again, there is a huge difference. So you can just do transactions within Bitcoin. In Ethereum, you can run a computer program, and that's a big deal. So it's a distributed computational platform. So remember, we did 7 different classes of cryptocurrencies. So Bitcoin was the first generation. Ethereum is the second generation, and there's a lot that can happen with it. So let me finish off by motivating the assignment number 4, which has been pushed out. So assignment number 4 actually gives you a short piece of code, which is about 15 lines, and it's highly documented so you can see what's going on. It's written in Solidity, which is the coding language for Ethereum. And this code, I think, is pretty special. What it will allow you to do is to place some data into a smart contract. So again, this is a key difference between Bitcoin and Ethereum. So once this smart contract is set up, you can actually add data to it. So you can't do anything like that in Bitcoin. So what you're going to do is to first deploy the smart contract, and it is your smart contract. Okay, we'll deploy it to the testnet, but again, you could deploy it to the actual real Ethereum blockchain. The same code is going to work the same way, except you'd have to pay for it. But not much, perhaps $1. So next, you're going to send a transaction to that contract, and you're going to have to pay for it in gas. And gas is not going to be that expensive, 10 cents of fake ether, but you're able to put something into that contract. So in the hashing assignment, we theoretically talked about the usefulness of putting a cryptographic hash into a blockchain. Well, this is no longer theory. You are actually going to do that. So you can hash any document you want and then place the hash into the Ethereum blockchain. So in doing that, we also allow you to link your address to that particular hash as the owner. So your public address is clear from your Ethereum wallet. And what you'll do is to put the hash into this contract, into your contract, and then you will link that hash to your public address. Okay, so that's kind of the first thing. So now you can actually put something, we talked about proof of authenticity. Well, now you've got something operational that you can actually do this with. So the second part of the assignment is kind of cool also. You can send another transaction to this contract whereby you can reassign the ownership of the hash to someone else. So in this particular case, you're going to reassign it to Joey, and Joey is going to get notice that you've reassigned the ownership of that hash. Okay, so after the technical parts of the assignment, there are 2 questions, and the questions relate to the business applications that you think could be relevant to what you've done in the assignment. This, to me, is an exciting assignment because it's one of the few assignments where you actually get a tool that you can use after you graduate. So good luck on that assignment. The technical part of the assignment can be done in a group, and the last two questions have to be done